Good morning, students. Here, analog electronics. Under analog electronics, we have 5 units, right? So in that, for first unit is p-n junction diode. So already we discussed in the class. So under p-n junction diode, what we discussed, just p-n junction diode. Under p-n junction diode, we discuss about the forward bias and reverse bias characteristics. The next, VI characteristics of p-n junction diode, right? So in that, first we need to know what about the what is meant by semiconductor. Okay, so semiconductor, that semiconductor is all matter is made up of atoms, right? So this atom consists of electrons, protons and neutrons. The materials can be classified into three groups called conductor, semiconductor, insulator. The semiconductor material is important because the configuration certain electrons is key factor to determine how to give the material conduct the environments. Okay, next, the atoms combining the formation of electron holes pair. Okay, so this also already we discussed in the class, how electron holes pair created, right? So when the atoms are combining to form of solid crystal material, they arrange themselves in the symmetric pattern. Within the symmetric pattern, it is created the covalent bonds. Okay, so the two types of semiconductor is there. First one is intrinsic semiconductor and extrinsic semiconductor. Before that, we need to know what about doping, right? So this is done by adding impurities. So by adding impurities is called doping in extrinsic materials. Okay, so in that intrinsic and extrinsic semiconductor. So under extrinsic semiconductor, we have two types. One is p type and n type. Okay, so the semiconductor diode conducting during forward bias, does not conduct it during reverse bias. Okay, in that, a piece of p-type semiconductor is joined p and p-n conductor. Okay, so next, so this is the first unit, forward bias, reverse bias, and then diffusion across the p-n junction diode. So what is diffusion? What is diffusion and depletion layer? When p-n junction is forward biased or if p-n junction is formed, the n region loses free electrons because these electrons was diffused across the junction. Hence they form a layer of positive charges near the junction. Similarly, p region loses holes because the electrons from the n region combines with the holes, so they form a layer of negative charges. So they form the layer of negative charges near the junctions. So these two layer of positive and negative charges forms a region as called depletion region. Okay, so from the p side, majority carries holes, right? So holes are moving towards the junction. From the n type material, majority carriers are electrons, right? So electrons are moves towards the junctions. So in that between junctions, electron holes pair created the depletion region. Here depletion refers to the fact that the region near the p-n junction is deflected or removed the charge carriers. Okay, the space region, transition region, depletion region is there. So next, VI characteristics of p-n junction diode. A p-n junction diode is also called as a semiconductor diode. Okay, so when we are applying the potential difference between the diode is called biasing. There are two types of biasing is there, right? So forward bias and reverse bias. Okay, that was we will discuss about drift current and diffusion current. So what is meant by drift current? When a potential difference is applied across a semiconductor, an electric field is developed in the material. It causes the free electrons. The free electrons drift in one direction and holes drift in another direction is called drift current. Okay, so from the continue, so the second unit is bipolar junction transistor, right? So in that bipolar junction transistor, we will discuss about what is BJT, what is bipolar junction what is BJT. Next, BJT, the construction of BJT. Next, BJT symbol, BJT operation. Next, transistor current components. So under transistor current components, we have three types: input output characteristics of transistor in CB configuration. CB configuration in the sense, common base configuration. Next one is input output characteristics of transistor in common emitter configuration. Next, input output characteristics of transistor in common collector configuration. Next, comparison of common emitter, common base and common collector. Next, BJT applications. Okay, so first, what does mean by BJT? A BJT, bipolar junction transistor, is a three-terminal device. So what are the three terminals? Emitter, base and collector. So it is a semiconductor device in which the operation depends upon the interaction of both majority carriers and minority carriers. So it is called as bipolar junction transistor. Before the transistor has two types. So one is unipolar junction transistor and bipolar junction transistor. So what is meant by unipolar junction transistor? The current conduction is only due to one type of carriers. So one type of carriers means majority carriers. So if it is p type, majority carrier is holes. If it is n type, majority carrier is electrons. Next, second type is bipolar junction transistor. The current conduction is only due to both majority carriers and minority carriers. So hence it is called as bipolar junction transistor. While coming to the application of transistor, transistor form a fundamental building blocks of the operations. Okay, so first one is NPN transistor. Second one is PNP transistor. Okay, so before that we discussed construction of BJT. The BJT consists of a silicon or germanium crystal in which thin layer of n-type silicon sandwiched between the two layers. Okay, so this is a p type. So center p type is there, right? So in that p type is sandwiched between the two layer of n type. So same here, n type is sandwiched between the two types of p layer. Okay, so next so NPN transistor means n-type silicon is sandwiched between the two p-type silicons. NPN transistor is p-type silicon sandwiched between two layers of the n-type semiconductor. Next, while coming to the construction, 3 points of the transistors are emitter, base and collector. Okay, so first point is emitter. So what the purpose of emitter is, the arrow indicates on the emitter specify the direction of the current flow of when emitter base junction is forward biased. Okay, so next, emitter is heavily doped so that it can inject a large number of charge carriers in the base. Okay, so here the first point is emitter, right? So emitter is used to carry the large amount of electrons and holes. If it is NPN transistor, it is electrons. If it is a PNP transistor, it is holes. Okay, so that's why it is called as heavily doped semiconductor. Next, moving to the base. A base is lightly doped and very thin. Okay, so it is used to passes the charge carriers from emitter into the collector. Next one is collector. Collector is moderately doped. Here NPN transistor collector is moderately doped. Most of the transistor collector regions are made physically larger than the emitter region. Okay, so nowadays we are maximum using the NPN transistor. Why NPN transistor means most of the current flows is due to the flow of electrons by compared to the PNP transistor. So majority of charge carrier is I. Okay, so next, while coming to the biasing of transistor. Okay, so what is meant by biasing? If the NPN transistor and PNP transistor will work under the biasing condition. So till a will operate only in order to operate transistor properly as an amplifier, it is need to biasing, right? So to PN junction to the external voltages. That external voltage is DC voltage. Usually the emitter base junction is forward bias. Okay, so here NPN transistor is there, right? So here emitter and base. So between emitter and base, between it is forward bias. Collector and base between reverse bias. Okay, so usually emitter base junction is forward bias and collector base junction is reverse bias. Due to the forward bias on the emitter base junction, emitter current flows through the base to the collector. base to the collector. Though the collector base junction is reverse bias, almost the entire current flows to the collector current. Okay, so next, operation of the NPN transistor. The circuit diagram shows the forward bias is connected between the forward bias supply is connected between the emitter and base circuits. Reverse bias is connected between the base and collector circuits. Okay, so here N type is majority electrons, collector side N type is majority electrons. In between thin layer base is majority carriers holes. Okay, so now moving to the operation. The forward bias is applied to the emitter base junction. When first case 1, the forward bias is applied to the emitter base junction. In that negative charge is there, right? So that negative charge and in N type majority carries electrons, right? So in that both negatives are repelled each other. We know that same polarity repel each other, right? So in VBE positive terminal, first terminal is positive, negative, right? So that negative and emitter side in N region majority carries electrons, right? So both negative charges are repel each other. Okay, so repel in the sense the electrons are move towards the base region. So in that base region the majority carrier is holes, right? So that holes are collected the electrons from the emitter and create the electron holes pair. Okay, so electron holes pair, remaining electrons are traveled towards the collector junction, collector N type semiconductor. Okay, so already in that N type majority carries electrons, right? So both the electrons are traveled together, and in that base collector between base collector reverse bias is there, right? So in that reverse bias first charge carrier is positive charge carriers. That positive carriers and N type electron carriers are positive negative, right? So electron negative. In that reverse biasing first conduction is positive charges, so that positive negative are attract together. So due to the attraction the electrons will move from the base. Okay, so in that the remaining electrons more than 95% in that base, right? So over collector region consists of collector current. In the external circuit of the NPN bipolar junction transistor, magnitude of the emitted current is I. Emitter current IE and base current is denoted by IB and collector current is denoted by IC. So hence it is denoted by IE equal to collector current plus base current. Emitter current is equal to the sum of collector current and base current. Okay, so as per the KCL law, the sum of IC is equal to IB equal to IE equal to 0. Okay, so next operation of PNP transistor. So first explain about the BJT bipolar junction transistor, and then explain about the construction of BJT, and while coming to the PNP transistor, same function as the diagram shows here. The diagram is there, right? This diagram shows the forward bias applied to the emitter base junction of the PNP transistor causes a lot of holes from the emitter region to cross over the base region. As the base is lightly daubed with a N-type impurity, the number of electrons in the base region or the base is very small, and hence the number of holes combined with electrons in the N-type base region is also very small. Hence, a few holes combined with the electrons to conserve base current IB. The remaining holes more than the 95% cross over into the collector region. Thus the collector and base current in PNP transistor IE equal to same IB plus IC. The current components in the transistors are, the figure shows below the various currents components. Okay, so one is hole current, reverse saturation current, electron current, and the reverse bipolar current. Okay, so in that first is what is meant by hole current. Hole current consists of hole crossing from the emitter to the base current. The current components in the transistor with forward bias emitter, reverse bias. Already we know that forward bias is connected between the emitter and base side. Reverse bias is connected between the collector and base side. Next, electron current. Electron current constituted by electrons crossing from base into the emitter. The holes crossing the emitter base junction reaching the collector base junction conserve collector current. Okay, so since base wide is very small, most of the holes cross the collector base junction JC. Okay, so while coming to the transistor configuration, already in that index part I told you it has a 3 types, right? So first one is common base configuration, common emitter configuration, common collector configuration. Basically 3 types. Okay, so in that detail we will discuss about common base configuration. Okay, so first, before that, when a transistor is to be connected in a circuit, one terminal is used as the input terminal. Okay, another terminal is used as the output terminal, and third terminal is common to the input and output. Third terminal is connected to input and output. So first, the configuration of CB, common base configuration, and the common base configuration is also called as grounded base configuration. In this configuration, emitter is input, the collector is output, the base is the common terminal. So 3 terminals is there, right? Emitter, base, collector. So in this 3, one is input, another one is output, and one more is common terminal. So likewise, in common base configuration is called as grounded base configuration. So hence the base is common terminal, input is emitter, output is collector. So in that common emitter configuration, this is also called as grounded emitter configuration. So emitter is common terminal, base is input terminal, collector is output terminal. So next, common collector configuration. This is also called as grounded collector configuration. This is also called as grounded collector configuration. In this configuration, base is the input terminal, emitter is output terminal, collector is common terminal. Okay, so in the detail we will discuss common base configuration. So common base, in the sense base is grounded, input is emitter, collector is output. Okay, the ratio of collector current is mentioned by emitter base forward bias divided by collector current I. Next, output impedance on the common base divided by collector current IC. The current amplification factor CB is given, right? So next we will discuss characteristics of input output characteristics of CB configuration. So first, input characteristics. So determine the input characteristics. The reading will be taken between the emitter base voltage VEB and emitter current IE at different constant level of collector base VCB. Okay, so here VCB is constant, the x-axis and y-axis is emitter current and base emitter voltage. When VCB is 0, the emitter base junction working under the forward bias diode, the emitter current increases radically. Here the emitter current radically with an increase of emitter base voltage when VCB is increased. So initially VCB is 0, here it is there, right? Initially VCB is 0, so at the time of 0 the emitter base junction is working the forward bias diode. The emitter current increases radically with an increasing the emitter base voltage. When VCB is increased, the wide base region is decreased, the emitter current also increased. While coming to the output characteristics, so to determine the output characteristics, the emitter current IE is kept at constant between VCB and ICE. So first 0 milliamps, next 1 milliamps, next 2 milliamps, 3 milliamps, 5 milliamps. IC flows when VCB is equal to 0. As the emitter base junction is forward bias, the majority carries electrons from the emitter injected into the base region due to the action of interval potential barrier at the reverse bias collector. Same likewise, common emitter configuration. Common emitter configuration is applied between the base and emitter output signal. The ratio of DC collector current output, DC collector current and base current is called the current gain. The collector current of a transistor is much larger than the base current. The ratio of DC collector current, then same likewise total current, total collector current. Next, while coming to the common emitter configuration, the diagram shows the common emitter configuration. The input characteristics under VC is first 0 volt. Next, VC equal to VC is greater than 0. Okay, the value of VB is noted for each setting of IB. This procedure is repeated for higher fixed values of curve. This curve shows the input characteristics of PN junction diode. Next, output characteristics of PN junction diode. To determine the output characteristics of PN junction diode, the base current IB is kept at constant at the suitable value by adjusting the base emitter voltage VBE. So in that graph it shows, right, saturation region, cutoff region. So what is meant by saturation region? The region of curves to the left of the line OA. So here OA is there, right? That OA is called saturation region. In this region, both junctions are forward bias and the increases the base current does not causes the corresponding large change in IC. Next, while coming to the cutoff region, the region below the curve for IB is 0. It is called cutoff region. In this region, both junctions are reverse bias when the operating point of transistor enter the cutoff region. So first one is saturation region, second one is cutoff region. So cutoff region is lies between the saturation region and active region. Next one is active region, the central region where the curves are uniform in spacing and slope is called the active region. In this region, emitter based junction is forward bias and the collector based junction is reverse bias of the transistor in linear applications. Next, input impedance, output impedance, forward current gain, reverse current gain. So, while coming to the comparison of CB, CE and CC, so first property input resistance. So according to the input resistance, the common base is low, about 100 ohms resistor. Next, common collector is moderate, common emitter is moderate, common collector is high. Output resistance high, moderate, low. The current gain of common base is 1, common collector is high, common emitter is high. The voltage gain of common base about 500, common emitter is about 500, common collector less than 1. And the specification of BJT in different conditions: active region, saturation region and cutoff regions. Okay, so what we discussed from the first, what is bipolar junction transistor. Next one is bipolar junction transistor. Next, operation of BJT. So under BJT we have two types: NPN transistor and PNP transistor. So what is meant by NPN transistor? The thin P type semiconductor is layered between the two N type semiconductor, so that's why it is called as NPN transistor. Okay, NPN transistor means in the input emitter, in between base the output is collector. Same likewise PNP transistor. While coming to the transistor current components, it has divided into three types: input output characteristics of transistor, common base configuration, common emitter configuration and common collector configuration. At last we discussed about the comparison of transistor in CB, CE and CC. Next, the specification of BJT under the various level. The important one is transistor current. The emitted current is the sum of collector current and the base current. IE equal to IB plus IC is called transistor current. Okay, so thank you, students.